All right, guys, I've done an example of each, so let's just do some word problems together because they're a little tougher to interpret words instead of just being given numbers to put and to draw and to just plug in formulas. So this word problem says the cylinder contains two congruent hollow cones. So I have this cylinder here. Inside my cylinder, I have a cone right there, if you guys see that cone, and then one facing down right there. Okay, those cones are hollow, they're empty, there's nothing inside of them. It says that if the cylinder's height is 20 inches, so this distance right there, the whole height is 20 inches, and its diameter is 14 inches. So if you guys remember, the diameter is the distance from one end of the circle to the other as it goes through the center. So I'm just going to draw that distance right there. That is 14. Okay, so that's 14 inches. It says find the volume of the cylinder. So something important to know and to think about is if these cones are empty, that means they're not taking any space. So I want to find how much space this does take up. So I'm not going to include these two cones. Okay, so I'm basically finding the volume of the cylinder without these two cones inside of it. So I'm just going to shade in the area that I do want to find. So basically I'm finding everything. If you imagine this in 3D, okay, imagine yourself putting an upside down cone in a can and then another one right side up. How much space is left inside and around that can? How much volume is that taking up? So the best way to do this is kind of like kind of the same rules that we use when we were finding the area of composite figures, or with a bunch of figures put together, the two-dimensional ones. Sometimes we added areas of the two, sometimes we subtracted areas because there were holes in those drawings, if you remember that and that makes sense. But we're just going to kind of use the same rules. So first I'm going to find the volume of this cylinder. Okay, and if you guys remember, I'm just going to find volume. I'm going to label this CYL. I'm going to put it tiny right there so I know that I'm finding the volume of the cylinder first, okay? Because I'm going to have a lot of volume formulas here in just a second. So the volume of a cylinder is pi r squared times the height, right? So it's basically big B times height. And remember, big B is the area of the base, and the bases are circular. So the area of the base is pi r squared times the height of that cylinder, h. Okay, so I'm going to plug in the things I know. So pi, we know what pi is, 3.14. R is the radius. It gave me the diameter. And remember, the radius is only half the diameter. So all I have to do with the diameter is split it in half so I can know just that radius, just this distance right there. So half of 14 is 7, or 14 divided by 2 equals 7. So my radius is 7 squared. And then the height of the cylinder is given to me, that is 20 inches. Okay, so if I just plug that into my calculator, I will end up getting 3,078.76 inches cubed. So that is the volume of the entire cylinder if it were all completely full. If it were not only taking up the space of the shape on the outside, but if it were full of something on the inside, okay? This whole cylinder's volume is that. So the volume of this cylinder is 3,078.76 inches cubed. Now I'm going to find the volume of these cones because I want to subtract that volume because I'm not including, there's no space being taken up because they are completely hollow. Okay, they're empty. So I'm going to put the volume of a cone. Okay, and the volume of a cone is 1/3 pi r squared, or 1/3 the base of the area times the height. So 1/3 times pi r squared, pi, that's only for one cone, okay? It's as if I were finding the volume. Let me actually do it in a different color so I know so you guys can see what I'm finding the volume of. So if I were to find the volume of this, I'm trying to find the empty space in here, okay? So the volume of a cone equals 1/3 times pi r squared, which is big B, right? The area of the base, pi, times the radius. We already found that the radius was 7 squared, times the height of this cone. So if these two cones are exactly equal, then that means that this height is the same as this height. If the full height of both of them is 20 inches, then all I need to do is find half of 20 to find the distance from here to here, the height of the actual cone, right? From here to there, making a 90-degree angle. So half of 20 is 10. So I know that the height of the cone is 10. Okay, then I calculate that and I get 513.12 inches cubed. So that is the volume of one of these cones. But I have two cones and they have the exact same measurement. So to find the volume of both cones put together, all I have to do is double that. Okay, so I'm just going to multiply by 2 because I am finding the volume of both of these cones. So if I multiply by 2, I end up with 1,026.25 inches cubed. Okay, so I know that the volume of this cylinder is 3,078.76 inches cubed, and I know that the volume of both cones put together is 1,026.25 inches cubed. Now I want to know the volume of the cylinder if those two cones were completely empty and hollow. So if I want to take away the volume that they take up, right? I want to remove that space because there's nothing occupying that space. It's hollow. I'm just going to subtract the volume of the cylinder by the volume of the cones, both the cones. And that should give me the volume of my entire cylinder with those two hollow parts. Okay, I'm going to erase all this to kind of make room for more. All right, so ideally, if I subtract the volume of the cylinder minus the volume of two cones, right, then that should give me the leftover space in there, the actual space that this cylinder is taking out with those two hollow cone-shaped areas. So I'm just going to plug in the things that I found, which I have written down already. I'm just rewriting them. So that is 3,078.76 minus 1,026.25. These were all in inches cubed. So I'm basically subtracting the volume of this whole cylinder minus these two cones put together. And I wind up with 2,052.51 inches squared, or inches cubed. Sorry. So that is the volume this actual cylinder takes up with these two hollow cones inside of it. All right, next problem. A cone has a volume of 1,309 centimeters cubed, If the height of the cone is 8 centimeters, find its radius. So you don't really have to draw a picture for this one. You just need to know the formula, but let's pretend we have a cone here. Okay, so the whole volume, all the space this cone takes up is equal to 1309 centimeters cubed. So I'm just going to underline that important piece of information. We know the height, so the distance from that top point to the base of the cone is 8 centimeters, so that's 8. And we want to find its radius. In other words, the distance from the center of the circle, or the base of the cone, to one of its edges. Okay, that's what we want to find out. That's our x, that's our variable. So all I need is the volume formula, because I have two very important pieces of information, the height of the cone and the volume of the cone. And we have a formula that has those two pieces of information, right? That is the volume equals 1/3 pi r squared times the height of the cone. So I'm just going to plug in the things I know. I know the volume, or V, is 1309. So I'm going to plug that in for V, right? Times 1/3 times pi, and I don't know the radius, okay? But I know the height. I know the height is 8. So I can just plug that in, and now I only have one variable to work with. That's all I need to do. I just need to find what R is. I don't need any additional steps besides that. So what I'm going to do is I'm just going to multiply all of this together. So 1309 is equal to 1/3 times pi times 8. That gives me 8.3, if I rounded, 8 times r squared. So now I have practically all of this, but I still want to leave r alone. So I want to find that radius, so I want to leave that variable alone. So that means I want to move everything on the other side of the equal sign. So I'm just going to do the opposite of whatever's happening to r. First, I can get rid of this 8.38, and it's being multiplied to r, so I'm going to do the opposite. I'm going to divide by that. And I get, if I had more space, I wind up with, let's see, I'm just going to erase actually. So this gets canceled out, and then 1309 divided by 8.38 is equal to 156.25. And since this canceled out, I can just leave r squared alone on that side, the equal sign. R squared. Well, the r is still not alone. I still need to get rid of something. There's still a little 2 up here. So squared means I have to double the r, but I know to find just r alone, I have to do the opposite. So the opposite of squaring is finding the square root. So I'm going to find the square root of both sides. Okay, so finding the square root of something squared just cancels those things out and just leaves this thing alone. So that tells me that r is equal to, and I just plug that into my calculator. I find the square root of 156.25, and that gives me 12.5 centimeters. Okay, and that should be my radius. My radius is 12.5 centimeters.